Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Yeah, is my screen visible, online students?
Yes, ma'am.
Yeah, please take down the third question. Yeah, children here, write down question number 3. Yeah, done writing, children? No? All right. So the question is, a cone is cut by a plane parallel to the base. So whenever we say a cone, it has to rest, right? You cannot, this is how a cone, an ice cream cone is, because you hold it in your hand. You don't leave the ice cream cone on a tabletop, right? The seller, he gives it to you and you hold it. So this is how you draw an ice cream cone. But otherwise, when we say cone, it always rests on its base like this. A cone is, we always draw a cone like this. Okay. Yeah, so the cone always rests on its base, circular base. And when you draw the cone like this is called an inverted cone. This one is called an inverted cone. This is how a cone looks like. This is how you draw a cone. And this is an inverted cone. The ice cream cone is an inverted cone. Because if it is a cone, it rests on the circular base. Now, what's given? A cone is cut by a plane parallel to the base. So cone you should draw resting on its circular base. A plane parallel to the base. There's a plane going past. This is the axis of the cone. This is the plane, a cutting plane, which is parallel to the base, the circular base of the cone. This is a cutting plane, which is parallel to the base, the circular base of the cone. Now this plane, you can see here, a cone is cut by a plane parallel to the base. This is the cutting plane. And this plane goes parallel to the base, and the upper part is removed. So this one is removed. So this one is a small cone. The upper part is a small cone that's removed. Now this remaining part is called the frustum of a cone. The remaining part is called the frustum of a cone. So this is the cutting plane which runs parallel to the base of the cone. and the top portion is removed, the top small cone is removed. If the CSA of the remainder, if the curved surface area of the remainder, so CSA of the remainder is CSA of the frustum. Which is the remainder? Remainder is the frustum, because when the small cone is removed, what remains is the frustum. When this one is removed, what remains is the frustum. So CSA of the remainder meaning CSA of the frustum. The frustum is the remainder. From the whole cone, when you take away the top small cone, what remains is the frustum of the cone. So the CSA of the remainder meaning CSA of the frustum. CSA of the frustum is equal to 15 by 16 of the CSA of the whole cone. Of meaning into. All right, CSA of the whole cone. CSA of the whole cone. So this is the equation we have. The equation we have is CSA of the frustum, the CSA of the remainder. So CSA of the frustum is equal to 15 by 16 into the CSA of the whole cone. The whole cone is the full cone. Before the top, before it was cut by a plane parallel to the base, the whole thing. So this equation we have from this question. Now what is it we have to find? We need to find the ratio in which the ratio of the line segments into which the cone's altitude is divided by the plane. So this is the cone's altitude. This is the altitude of the cone. See here? This is the altitude of the cone. Now, since this plane, this is the cutting plane, this cutting plane cuts the axis of the cone or the altitude of the cone into two pieces. See here? One here and one here. These are the two pieces or these are the two segments of the altitude of the whole cone. Why do we have the two segments now? It's because of the cutting plane. All right. So this is the altitude of the cone. This is the altitude of the cone. So since this plane cuts the cone into two pieces, okay, the height is also cut into two pieces. The whole altitude is also cut into two pieces. So you can see this one. This is the height of the small cone, and this is the height of the frustum. The altitude of the cone is divided into two segments because of the cutting plane. The whole altitude of the cone is divided into two segments. The top segment is the height of the small cone and the bottom segment is the height of the frustum. We need to find this ratio. See that? Find the ratio of the line segments. Find the ratio of the line segments. These are the two line segments spoken about. See there, of the line segments into which the cone's altitude is divided by the plane. So which are the two segments? These are the two segments, this segment and this segment. So you should find the ratio of the line segments. Ratio of the line segment. That means you should find the length of this line segment by the length of this line segment. Find the ratio of the line segments into which the cone's altitude is divided by the plane. Is the cone's altitude divided by the plane? Is the cone's altitude divided, cut because of the plane? Yes. Into how many pieces? Two pieces. So those are the two line segments. You need to find the ratio of these two line segments. All right. So you understand the diagram. You understand the diagram. So this is the plane which cuts through the cone parallel to the base. This is the plane. This is the plane. Plane is something flat. Something flat is a plane. Anything flat. Plane meaning like something sharp and flat is a plane. So this is the plane. All right. So this is the small cone. This is the whole cone. Now we are not talking about the frustum. This remaining portion is called the frustum, but we are not marking off anything of the frustum. So we are going to talk in terms of small cone and big cone. We're going to talk in terms of small cone and big cone. And in that equation, we have frustum, no? That also will replace using small cone and big cone. In that equation, we had no CSA of the remainder, that is CSA of the frustum, is equal to 15 by 16 of the CSA of the whole cone. We had that equation, right? There also that word frustum will replace with small cone and whole cone. We'll see that, okay? So we are not writing anything of the frustum. So you can see a small cone. Radius is D, right? Okay, if I zoom in, I cannot annotate. Is it clear? Not Ritika. Navya, sorry, Navya. Navya. Yes, children, sorry. So this is the radius of the small cone. This is the height of the small cone. This is the slant height of the small cone. And why are we talking about the slant height? Because the equation is in terms of curved surface area. And CSA of a cone is pi RL. If it was volume, then we'll not talk about slant height. If it was about volume, we'll not talk about slant height because volume is 1/3 pi r square h. We only need R and H for volume. But because it is CSA, we need R and L. R, H for volume. When it comes to a cone, for a cone, it is R and H for volume, R and L for curved surface area or total surface area. All right. So this is the radius of the small cone. DE, D is the radius. The perpendicular height is AD. And the slant height is AE. The slant height is AE, correct? Now for the whole cone, BC is the radius. BC is the radius. We use a capital letter R. And AB is the altitude. AB is the altitude, capital letter H. And AC is the slant height, capital letter L. So small letters for small cone, capital letters for whole cone. Nothing we have mentioned about the frustum here. Okay, now write the equation which is given in the question. CSA of the frustum, CSA of the remainder, meaning CSA of the frustum is equal to 15 by 16 into CSA of whole cone, children. This is WC is whole cone. All right, this is what is given to us. So as we understood, let's replace this frustum with big cone and small cone. So the CSA of the whole cone, CSA, not TSA, CSA. So CSA of the whole cone minus the CSA of the small cone will be the CSA of the frustum, right? Only the curved surface area we're talking about. See, this is the curved surface area of the whole cone. This is the curved surface area of the whole cone. The curved surface area of the whole cone minus the curved surface area of the small cone will be the curved surface area of the frustum, right? This full thing, this one is the curved surface area of the whole cone. From that, if you take away the curved surface area of the small cone, you will be left with the CSA of the frustum. So CSA of the frustum can be written as CSA of the whole cone minus the CSA of the small cone. That is CSA of the big cone minus the CSA of the small cone. We understand that? Okay. So this is replaced. CSA of the frustum is replaced with CSA of the whole cone minus the CSA of small cone. And this one I've brought it here for division. This one, the CSA of the whole cone comes down to the other side. I'm just maintaining a ratio. See this one. This one comes to the other side. See, we have CSA is equal to 15 by 16 and into CSA here, right? The CSA I've brought it here for division. Okay, so this is the equation we have in the question. CSA of the frustum is replaced with CSA of the whole cone minus the CSA of the small cone. And this one comes down to the other side for division. CSA of the whole cone is equal to 15 by 16. Now, when you have A minus B by B, you can write it as, okay, let me write A minus B by A. When you have A minus B by A, you can write it as A by A minus B by A. That gives us 1 minus B by A. A minus B by A can be written as A by A minus B by A. A by A is 1 minus B by A. That's what we have done here also. So CSA of the whole cone by the CSA of the whole cone will be 1. CSA of the whole cone by the CSA of the whole cone is 1 minus CSA of small cone by CSA of whole cone. Apply this here, children. Yeah, apply this one here. Now you can write that additional step. You can write that CSA of whole cone divided by CSA of whole cone minus CSA of small cone divided by CSA of whole cone. So CSA of whole cone by CSA of whole cone is 1 minus CSA of small cone by CSA of whole cone is equal to 15 by 16. Now this you can transpose like, okay. So this step, children, this step. So it will be 1 minus 15 by 16 is equal to CSA of small cone by CSA of whole cone, right? Just gathering the numbers on one side. So it will be like 1 minus 15 by 16. 1 minus 15 by 16 is equal to CSA. Because it's minus, no? It's minus. It will go to the other side as plus. So it will be 1 minus 15 by 16 is equal to CSA of small cone by CSA of whole cone. When you take the LCM, 16 is a common denominator. So you get 16 minus 15. So you get 1 by 16. We get 1 by 16. So CSA of small cone by CSA of whole cone is equal to 1 by 16. Is equal to 1 by 16. Please show those steps in the middle. Okay. So now we have CSA of small cone by whole cone is equal to 1 by 16. Now let's use the formula. Now we know the formula. No? CSA of small cone, CSA of whole cone. So CSA of small cone will be pi small r small l. Whole cone will be pi capital R capital L. CSA formula. CSA of a cone is pi RL. For the small cone, use small r small l. For the big cone, capital R capital L. Is equal to 1 by 16. So now pi gets cancelled in the numerator and the denominator. Pi gets cancelled and we have r by r. We have r by r is equal to L by L. Now we are going to use similarity to proceed. Okay. Now look at this triangle ADE, the small triangle ADE and this whole triangle ABC are similar to each other. The small triangle ADE is a right triangle because this is 90. The whole triangle ABC is also a right triangle. This is 90. And then this is the common angle. This vertex angle is a common angle, not the entire vertex angle. This half of the vertex angle, only this one. Angle DAE is equal to BAC, common angle. Because it is in the small triangle as well as the whole. See, when we take the whole triangle, it is this full triangle, including the small triangle it is. The whole triangle includes the small triangle. So that's the common vertex. This one is a common vertex and then 90 degrees. So by AA similarity criterion, the two triangles are similar to each other. So how do you write that? Triangle ADE is similar to triangle ABC by AA similarity criterion. ADE, ABC. So what do we have? We have AD by AB. Let me write it in terms of the symbols itself, children. Let me write it in terms of symbols. What is the AD by AB? Okay, fine. Let me write. I'm sorry. AD by AB is equal to DE by BC is equal to AE by AC. Now, what is AD? What is AD, children? H, small h. What's AB? Capital H. What is DE? Small r. BC? Capital R. AE? Small l. AC? Capital L. So what do we understand from this? H by H is equal to R by R is equal to L by L. That means here, look at this. R by R, L by L, they're equal. What do you understand by this? This is nothing but R by R into L by L. That's the meaning. This one. R by R into L by L. R by R into L by L. Now, we have to find the ratio of the altitudes. H by H. But we don't have that at all. But we know that both these ratios are equal to H by H. Both these ratios are equal to H by H. R by R, see from this one, we understand that this R by R, this one is equal to H by H. And what about L by L? That is also equal to H by H. All the three ratios are equal. And now we don't want R by R or L by L because we want to compare the ratios of the we want to compare the altitudes, the perpendicular heights of the small cone and the big cone. No, small cone and the frustum. Small cone and the frustum, right? We need to compare the heights of the small cone and the frustum. Compare the heights of the small cone and the frustum. We have to find the ratio of the line segments into which the cone's altitude is cut by the plane. Find the ratio. Are you sleeping, Sashank? You're tired? Okay. Yeah. You can, if so, you can just help yourself. Okay. Yeah, we need to find the ratio of the line segments into which the cone's altitude is cut by the plane. So the full altitude is cut into two parts, small cone's height and frustum's height. That's what we have to find. Okay, but we don't have H is not at all in picture. So now we're going to introduce H. We're getting H into the picture now. How R by R is replaced with H by H. L by L is also replaced with H by H. Correct? Okay, so successfully we got. So this after this you can proceed like this, children. You can proceed like this. So you write H by H into H by H is equal to 1 by 16. So H by H, the whole square is equal to 1 by 16. So H by H is equal to 1 by 4. 1 by 4. That means H is equal to 1x and capital H is equal to 4x. Correct? So how much is this one? This one is 1x. And the whole thing, this whole thing is 4x. Please understand. H is the height of the small cone. And capital H is the height of the whole cone. So then what is the height of the frustum in terms of x? 3x. The height of the frustum in terms of x is 3x because the full thing is 4x. And the small cone's height is x. So the height of the frustum is 4x minus x, 3x. So now the ratio is x by 3x, which is 1 by 3. You don't have to find their actual lengths. You cannot find, in fact, what actually their lengths are, we cannot find. This is the ratio of their lengths. The only ratio you can find. You cannot find their actual lengths. So we don't have frustum. Frustum is deleted from the syllabus, but this is nothing to do with the frustum. You can see that we have not used any formula related to a frustum here. It's completely based on cone. So this is a part of your syllabus. Though we have this word frustum here, it is a part of your syllabus. All right. Very important also. Yeah, start working, children. The answer is on the complete answer is on the next slide. It continues here. Finish this, I'll take you to the next slide. Please write, and any questions you can ask me later, children. Finish writing and then you can ask me if you have any doubts. Okay. Come here, just check your work. This week here. I think that I need the questions. Yes. You don't have to write the question, is it?
Actually, interchange different state.
You should repeat that thing. I don't think your teacher will be okay if you just show the areas like this.
When I go home, I'll put white here, but
Oh.
here I put it in correct.
Okay, fine. So you'll go home and correct that, is it? Okay. This one is right? I'll check it.
Yeah.
You can use that X which I told you, children. Since I explained like this, I worked in a different way here. This is also fine, but I'll just do that X method. This is not incorrect, please. This is not incorrect. This is correct, but you can just say HB equal to X, HB equal to 4X. Yeah, now you can do this.
Ma'am, can you show the previous slide just once?
Yeah, sure. Yeah. Done?
Yes, ma'am.
Yeah. You should write this one first. No? Here also, no, I'll tell you one thing. You repeat this because in the next step also you can this one first. Oh, you're saying you've put the signs correctly, is it? No, no. Next step also you've written this one, first. No, I'll tell you one thing. Repeat this. Yeah. That's good. The second one is
Here the index we do it in the book. I'm doing it. If you put some like fast, we have to do first 6 and 7. I'm doing that.
Yeah.
Big fast.
that yesterday I corrected. You've already done it.
So maybe
You work it and go home and check it out. If you have your tuition notebook, you can check it from it. But do it without. This is correct. I want you to repeat this one. So after getting this h by h 1 by 4, let small h be x. So capital X will be 4x, right? Yeah. So capital H is 4h. Capital H is 4x. But what is the height of the frustum called? Capital H minus small h. That's the height of the frustum. So that will be, that h minus h will be 3x. Why are we finding h minus h? Because total height minus small cone's height is the frustum's height. So we need to find that 3x. Now the required ratio is the small cone's height h by the frustum's height h minus h. The small cone h and the frustum h minus h, which is x by 3x or 1 by 3. All right. Done writing, online students?
Yes, ma'am.
Completed.
Okay. Yeah. Please take down the fourth one. So the diagram represents an ice cream cone. I've mentioned that below. And the question is a paragraph. I've just written the details given in the question. What is given in the question is the radius of the hemisphere. You can see where the hemisphere sits. The hemisphere sits on the outer cone, not the inner cone. That the thickness, the cone looks thick, no? There's that wall of the cone. Okay, this is an ice cream cone. So you know that the cone, that wafer cone is thick, right? The wafer cone which we eat after eating the ice cream, we also eat the ice cream, not the, yeah, the wafer cone. Okay, we eat the wafer cone also. That wall is thick. That's why it is shown like this here. The gap between these two lines represent the thickness of the wafer cone. All right. Okay. So what is given? The radius of the hemisphere. The hemisphere sits on the outer cone. There are two cones, one inner cone and one outer cone. Okay, so the hemisphere sits on the outer cone. That's one thing. The height of the cone is 10.5 centimeters. Now you should understand what is height of the cone. Is it NF or NB? NB, because height of the cone means height of the whole cone. Height of the cone means it's the height of the whole cone. It's not the inner height. Height means the external height. Height of the cone means the external height, the height of the cone. When you have the cone in your hand, the whole height of the cone. So the external height is 10.5. And all those details are given to you, parallel lines and all that. What you need to find is, so given is given in the question. When you read the question, you can, get all this information. Now you need to find the volume of the ice cream in the cone and also the volume of the outer shell. Volume of the outer shell and the volume of the ice cream in the cone. Yeah. That's what you have to find. So you need to find what are the three things you see here? One small cone, that is the inner cone. Please listen. The three things we see here are the inner cone, the small cone, the outer cone, the bigger cone, and the hemisphere. Now, what are we looking for? For the hemisphere, you need the radius that is given. For the two cones, you need at least two of their three values. For the cones, we have radius, perpendicular height, and slant height. Of these three, you should know at least two. Then you can find the third one if you want using the relation. Correct? So you need at least two. So check if you know the radius of the small cone and the big cone, the height of the small cone and the big cone. Maybe you can find the slant height if you want, but you don't need the slant height because it's only about volume. It's not about area. But for a cone, only if it's about area, you need slant height. Otherwise, you don't need slant height. So for the hemisphere, you need to have the radius, and for the cones, you need to have their radii and their perpendicular heights. So check if you have all of them. Yeah, check. Write down the question and check that. I'll get back. So I picked these two questions to, understand how we use the concepts of similar triangles here. So in the earlier one, we used similarity in two triangles. So here we'll be using another one from the same chapter. We'll see that. Okay, done writing, children?
Yes, ma'am.
Yeah. So shell is that wafer I was telling. So outer shell meaning the talking about the wafer. Shell means the wafer here. So to find the volume of the wafer, it's the volume of the outer cone minus the volume of the inner cone. Well, that's what it is. So don't get confused the word outer there. The outer shell is the shell. Shell itself means that wafer portion. All right. Okay. So yeah. So the volume of the ice cream in the cone. Yes. Who can tell me? How do we find? Just tell me in words. Tell me in words. Like this one plus this one minus that one plus this one minus that one, something like that. Yes.
That's the volume.
Very good. Volume of the ice cream in the cone. Volume of the ice cream in the cone is equal to volume of the inner cone plus the volume of the hemisphere. Because ice cream is filled inside the cone also, right? And which part of the which cone? The inner cone. Ice cream is filled in the inner cone, and then there's a hemispherical top also. That's how ice cream is served, right? The inner cone is stuffed with ice cream. We're not considering the air holes and all that. Maybe it's not completely filled. There will be some air holes. there'll not be ice cream somewhere inside, like you understand what I'm saying. So we are not considering all that. So ice cream is filled in the inner cone and there's a hemispherical top also. So the volume of the ice, the question is find the volume of the ice cream in the cone. The volume of the ice cream in the cone is volume of the inner cone plus the volume of the hemisphere. Now for the inner cone, do we know the radius and height? We can find out. I'll just explain and then show you the answer slide, children. You can help yourself using that one. Okay. Yeah, children. So now for the hemisphere, what is the radius? What's the radius of the hemisphere? 3.5 centimeters. Now for the outer cone, let's use capital R and capital H. Okay, so outer cone, capital R, do you know capital R? What is that? 3.5. Because the radius of the hemisphere is also the radius of the outer cone. Because the hemisphere sits on the outer cone. So the radius of the hemisphere and the radius of the outer cone will be the same. So let me write this as capital R. 3.5 centimeters. H we don't know. Then inner cone or small cone, inner cone, we need R and H. Yeah, do we know the height of the whole cone, children? 10.5. Radius of the inner cone? 3. How did we find out so easily? Because A is 0.5. This one is 0.5. Okay. This one is how much? How much is this one? 0.5. This one? 0. Okay. Okay. So you get the radius of the inner cone as 3. Okay. Then what about the height? Height is 10. But do you think this thickness also will be the same? No one. Do you think this one will be the same? No, just imagine. In the bottom, do you think that thickness will be the same? The wall will be uniformly thick. Then the apex of the cone below, how can you say that? It's very clearly given that AE is equal to DC. It's not given it's equal to FB. No, that's not the thickness of, that's not the wall of the cone. See, AE and DC, that is the wall of the cone, thickness of the wafer. But below there, at the bottom is not the thickness of the wafer there below. And it's also not given that it's equal to FB. AE is equal to DC is equal to FB is not given. And that portion below is not the thickness of the wafer, which is on the top, 0.5. That's about the height. FB is the difference in the height. Yeah. So here we can use BPT. I'll just say BPT and the rest you can do it yourself. Yeah. Okay. So we can use BPT here. So look at this triangle, children. You can take up this triangle or the triangle on the other side. Look at this triangle. This triangle. Okay. This triangle. Or you can take up this triangle here. Any one of the two you can take up. So let's see that here. So it's like okay, so these two lines are given to be parallel. You can see that AB is parallel to EF. AB is parallel to EF is given. Right? So in triangle A and B, in a triangle, you have a line through the triangle EF, and EF is parallel to that side AB. So you can use BPT, right? You can use BPT. So the sides are proportional. By BPT, the sides are proportional. In triangle A and B, EF is parallel to AB is given. So by BPT, we have NE by NA. The sides are proportional. Or you can write NE by EA also. NE, so what's the proportion you have? NE by EA is equal to NF by FB. You can also write, this is not going to be very useful. So you can write that, you can use this, or you can directly write NE by what? NE by NA is equal to NF by NB. These are the other results by BPT. NE by NA is equal to NF by NB. Right? So you can use this proportion, substitute the known values and find the unknowns. And hence answer the questions. We just want the values of R and H. Once you have them, you can answer these questions. Yeah. I'll just show you the answer. Please understand and then write down. Yeah, Chal. You finished it? Yeah. Come.
For 6, I have to do it in practice now. I actually did it in my practice, but I could not.
Okay, now what you
So,
do? This one. This is the question.
Yeah.
No brackets, nothing. Where the 6P you put here, you should put it here. No?
Like this, so I just put.
No, when you wrote 4P and minus 8P, you should have written plus 6P along with that.
2 pads can come.
No, no, it's not in.
But then, after I did these two, I just this.
Like you write these 3 numbers, you can write those 3 terms also. This is plus 1, no? Minus 7 plus 8 is plus 1.
I put it plus right.
Correct. This also will be plus 4x5 because minus 1 plus 5. Here also plus greater number sign, no? Plus. Here also plus. 2 is correct, but it's plus 2 and plus 4. Correct. You finished? Your homework is done, is it? Give me.
Ma'am,
Yeah, done writing?
ma'am, I have a doubt.
Yeah, sure.
Ma'am, how did 3 by 0.5 become 6, ma'am?
Yeah, 3 by 0.56, no? 3 divided by half is 6. Okay, then you multiply the numerator and denominator by 10, okay? Multiply the numerator and denominator by 10. So it will become 30 by 5, right? 30 by 5 is 6.
Yes, ma'am.
3 by 0.5 into 10, multiply 3 by 10 and 0.5 by 10, multiplying the numerator and denominator by 10. So that will give us 30 by 5. 30 by 5 is 6. Okay.
Yes, ma'am.
Can we go to the next slide? Finished all? Yeah. Textbook.
The exam paper, there was actually a question that had like the names saying, they gave it in cabinet. It was not to
Once again. Yeah, somebody called me.
at all, because it is, we did not learn in class yet. For us, they do not, like, they won't ask if we took large numbers of large letters. And she told it was like, I cannot just put L, I should put like P L or S L, that's the basic thing. You should name the whole line, like, if I just put an L, like, you have to like P L, like that.
That also it was wrong. No?
Yeah.
When they made a mistake with the question, how can children assume that this should be written, that should be written?
Yes.
She is just justifying her point. Basically. Did you do this paper from lessons?
Yes,
Did you finish it? There were not fractions. This paper. But I think we did a lot of fractions now recently. They do something which I've not done, and some paper which I've not tried from this.
those factors in
Villa Medran Mishri.
the lessons we take down.
Because in NCRT, algebra is not what you have in Agarwal. Yeah. So maybe the day we're doing a test paper on fractions from this book. You can continue with it. Remember?
There's not really much.
No, you were doing this one already. These fractions.
It's when I started showing papers.
Ma'am, how did it become 63 in the first line?
Come again?
Ma'am, how did it become 63 in the first line?
63. How Navya? 63? 10.5 into 6, no? 10.5 into 6. Rakshita, yes, you can ask me again. 10 cross multiplying 10.5 into 6.
Okay, ma'am. Okay.
Yeah. இது கம்ப்ளீட் பண்ணி
I those two next.
this one.
Third one. Okay.
Yeah.
Can I do it with page 57?
Yeah, yes, correct. Yeah. All right, so volume of ice cream, we understood inner cone plus hemisphere. So inner cone is 1/3 pi r square h, right? Finish writing, online students? Anyone still writing?
No, ma'am.
Yeah, just listen, no? So, Arjun and others. So when we say 1/3 pi r square h, 1/3 pi r square, I've mentioned the radius nd square. You understand what I've written? Radius is nd square into h nf for the inner cone. 1/3 pi r square h. This is formula 1/3 pi r square h plus hemisphere 2/3 pi r cubed, right? So I mentioned the radius nc cubed. You can write like this. All right. So it's easy to substitute the values now. I've taken 1/3 pi common, children. 1/3 pi is common. 1/3 pi is common. So you will get nd square. When you see the value, it is 3 square into nf 9 plus 1/3 is outside common. So 1/3 into 2 is only 2/3. 1 by 3 into 2 is 2 by 3. 1 by 3 is common, but here you have 2 by 3. So what should you write inside? 2 you must write. Because 1 by 3, this 1 by 3 into 2 will give you 2 by 3. Understand? Okay, so that's what you see here. 1 by 3 pi is common. 1 by 3 pi, 2 by 3 pi. 1 by 3 pi is common. Is common, and you will get this one when you substitute the values 3 square into 9. Here we have 2 by 3 pi. 1 by 3 is outside, so put a 2 here. So 2 by 3. Pi is already outside, so NC cubed, 3.5 cubed. So this 3 square is 9, 9 nines are 81. You should have worked all that. 3 square is 9, 9 nines are 81. This one is 81 plus 3.5 cubed. So 3 for the 12, 12.25 into 2. So some answer, and that plus 81 gives 166.75. And then after, like multiplying and dividing, this is the volume of the cone. Outer shell, volume of the outer cone minus the volume of the inner cone. 1 by 3 pi r square h, 1 by 3 pi r square h. So 1 by 3 pi is common. Yeah, you understand this, right? After that, substituting the values. Yeah. So you can see here we have used BPT. The earlier one we used similar triangles. Did we get that little portion as 0.5? Huh? Ah. Done writing? Yeah. Next one. Finished, Sashank? Don't draw the figure, children. Please write down the question alone. A right triangle whose sides are 15 centimeters and 20 centimeters is made to revolve about its hypotenuse. Find the volume and the surface area of the double cone so formed. Please write the question alone. It's cold? Oh, yeah. Done? Yeah.
Completed, ma'am.
Yeah, online students use the emoji. Raise your hand. Rajat, Madhumita, Krishmi, Danya, Rakshita, Florentina, and Raghavi. All right, thank you, children. Yeah. So here we have a right triangle. Right, so here we have a right triangle. Is it visible, children?
Yes, ma'am.
Okay. All right. So when you turn the right triangle, so this is the leg of the right triangle. This also is the leg of the right triangle. This is the hypotenuse. So we've learned in standard 9 that when a right triangle is made to turn about one of its legs, if you turn it like, see, this is one leg. You keep this leg as the axis, meaning you don't turn this. You keep this as a fixed line and you turn the triangle about this axis, You make one turn and you come back to the starting point. So the shape traced by this right triangle is a right circular cone. The right triangle does not become a right circular cone. The right triangle is a right triangle only. It cannot become a right circular cone, but a solid traced when this right triangle makes one rotation about this axis. About this axis meaning we're keeping this one as the axis, this one as a fixed line. When you turn it about that, about this leg, the solid generated is a right circular cone. The height of the cone is this one. This is the height of the cone. This will be the radius of the cone. And this will be the slant height of the cone. So the three sides of the triangle become the three values of the cone. This leg of the triangle becomes h of the cone. This leg of the triangle becomes r of the cone. And the hypotenuse becomes L of the cone. Now, when you turn it about this leg, if you keep the triangle like this, and if you turn it about this leg, you turn it about this leg, same thing. The solid generated or the solid traced is a right circular cone. So see, this is like that. This is the fixed point, and this is the radius. And when you turn, you can see it. This one will describe a circle. This one will describe a circle when you turn. So when you turn it about this leg, same thing happens. This one becomes the height of the cone, h. This is the radius of the cone, and this is the slant height of the cone. But when you turn a right triangle about its hypotenuse, so like this is the hypotenuse. This is the hypotenuse. Is the paper blurred or are you able to see it clearly, children, online students?
It's
Yes,
clear.
ma'am.
Clear.
All right, yeah. So now see, I'm having the right triangle like this with the hypotenuse here. This is the hypotenuse. I've turned it so that the hypotenuse is like this for me. It is, I can see it as a line, straight line now. Now I turn this right triangle about its hypotenuse. So see here, I keep it like this and I go like this. I go like this. I come back to the starting point. I make one turn. Then what happens is two cones are generated. One cone on this side and another cone on this side. You can just watch a video. You can imagine now, or you can just check it in the internet. You can also see a video like what happens when you turn a right triangle about its hypotenuse. When you turn a right triangle about one of its legs, then the solid generated is a right circular cone, one right circular cone. But when you turn the right triangle about its hypotenuse, a double cone is generated, a double cone is formed. You see, so when you turn, so this is the hypotenuse, and we go like this. So we make one turn, like we go like this, and we come back to the starting point. So there's a cone generated on this side and another cone generated on this side. So the two cones are stuck to each other. The two cones are stuck to each other. You cannot see in the cone generated, you cannot see the circular faces. It's like two cones are stuck together. One cone on this side, another cone on this side. You get a double cone when you turn the right triangle about its hypotenuse. So that's the question here. A right triangle is made to turn about its hypotenuse. Find the volume and the surface area of the double cone formed. Find the volume and the surface area of the double cone formed. So volume will be volume of the small cone plus the volume of the big cone. What will be the volume of the double cone? Volume of the small cone plus the volume of the big cone. And what will be the surface area of the double cone? CSA of the small cone plus the CSA of the big cone. I'm just using small, big, like, or one cone, other cone, you can say. CSA, the surface area of the double cone will be, because the circles are not, like the circles are intact, they are not seen. So it's not TSA. It's not TSA. It is CSA of one cone plus the CSA of the other. So we just need the values RHL. If we have these values, it's easy. It's just the formula we're going to use 1/3 pi r square h and pi rl. That's all. Nothing else. So you're right with me, children. $15.20. Let me make it look like 15, 20. Finished? Go to the next one. I'll come to you. Dileeban, your mic is enabled. I think please disable your mic. See, I want to draw it like this, but it's too small there. So let's see it like this, children. Please see here. So this is one cone. Can you get it now? Can you see that? This is how the cones will look like. The two cones stuck to each other like this. I'm not showing the circular portion here. I'll just use a line segment. Okay, I'll just connect it with the, I said I'm not showing the circular portion like this. I'll just use a line segment. Okay. So I'm just connecting it like this, children. Okay. So you can find the area of the triangle ABC in two ways. Okay, you finish it. You write down it. All right. So you can find the area of the triangle in two different ways. See it? Please listen. Don't see this working. This is different. When you have a right triangle, see, we know all the sides. This is 15, this is 20, and this is 25, right? So you can find the area of the right triangle ABC. This is 90 degrees. So using the formula half base into height, half into base AB into height AC, half product of legs, half into product of legs. Formula to find the area of a right triangle, half product of legs. The legs are AB and AC. Why? Because they're the sides containing the right angle. So half into AB into AC, half into product of legs. So you can find it like this. So half into 15 into 20, 150 centimeters square. The area of the same triangle you can find using the formula half into base BC into height AO. Area of the same triangle you can find using the formula half into base BC into height AO, correct? That also will be 150 only because same triangle, no? So like this, you can find half into what is the base 25 into AO is equal to 150. So AO is equal to 150 into 2 by 25, which is 6. Sorry, 12. Huh? Is the idea understood, children? We are finding the area of the same triangle in two different ways. Two different ways meaning using different base and heights. So that's what I worked here. Area of triangle ABC using half AB into AC first. We get 150. We got the area. Now find the area of the same triangle using the formula half into BC into height AO. So you get half into 25 into AO. Now half into 25 into AO will also be 150, right? So when you work that, you get AO is equal to 150 into 2 by 25, which is 12. Yes or no, children? Okay, now we found AO. You know what? This itself is enough to find the volumes and surface area of the double cone. The volume and the surface areas of the volume and the surface area of the double cone. So volume of the double cone. Volume of the double cone. One second. Is equal to what's the volume of the double cone? 1 by 3 pi, which is r square, into h, which is h. H is OC. Okay, for this time, okay, OC. Or for the other, for the smaller one, OB. Yeah, into OB. Plus 1 by 3 pi r square. OA square. Okay, AO square, sorry. Into H. What's H? O? OC. Now what is common, children? 1 by 3 pi into AO square is common. So in the bracket you will have OB plus OC. So that is 1 by 3 into pi, was it given 3.14? Okay, 3.14 into AO square, 12 square, so 12 into 12 into, we don't know OB and OC. How much is OB? I don't know. We don't know. How much is OC? No, we don't know. But what is OB plus OC? 25. So find In the same way, work the surface area. Surface area will be what? Pi r L. Pi RL plus pi RL. So use the line segments for R and L. Work it like this. Take out whatever common and do it. Yeah. Calculate it.
$3,768, ma'am.
Oh, okay. Aishwarya, not Aishwarya. It's Madhumita. Yeah. I'll tell you. Just give me 5 minutes. I'll just tell you.
Yes, ma'am.
Ma'am, I got 3768, ma'am.
I got 3,768.
Yes, children. I'll just tell you. Give me a minute. Yeah, what's the answer? Yes. Yeah, yes, all of you were right. 3,768 centimeter cubed. All right. So nothing from the right triangle, we found the hypotenuse, right? Using Pythagoras theorem, 25. And then we try to represent the double cone. Here, this is the representation of the double cone, this one. What is this? This is one cone. See, this is one cone. And this is the other cone. This is the other cone. This side, on the left side, you see one cone. On the right side, you see the other cone. They're stuck to each other. Right? Now, what did we do? We found the area of the triangle ABC. We found the area of the triangle ABC using the formula half product of legs. Half into AB into AC. 15 into 20, we got 150. The area of the same triangle ABC you can find using half into base BC into height AO. Like that, we find the length of the line segment AO, which is the common radius for the two cones. The two cones are of different sizes. The two cones are of different sizes, but the radius, the slant height is different for both the cones. For one cone, the slant height is 15. For the other cone, the slant height is 20. The perpendicular heights are also different for the two cones. For the small cone, it is BO. For the big cone, it is CO. The radius is the only thing which is common to both the cones. Since they have the same circular faces, they are stuck to each other. The radius of the two cones, the radius of the two cones is the same. That is AO. The height of the small cone, the height of the small cone is BO. The height of the big cone is CO. Correct? It's not anywhere in the hall. It is only on the board. Okay, BO and CO, correct? And then the slant height, which is the slant height of the small cone, AB, or you can even say BB dash. And the slant height of the big cone, you can say is AC or B dash C. This is 15. You know, this is 15. This is 20. Okay. So the thing is, it is enough if you find the radius. It is enough if you find the radius. You don't have to find the other values. Remember this. For the double cone, you don't have to find any other value. To find the volume of the double cone, see, we just needed the value of AO. Because we have to use OB and OC separately here, but then when you take out common, you get OB plus OC, which is nothing but BC and which is 25. So for the double cone, you don't have to find the heights separately for the two cones. It's enough if you find the radius. Yeah. Oh, yeah. Okay. Yeah. See, leave your books. Yeah, leave both books. Yes. Now, found the answer for surface area also? Surface area? What's the surface area? How much? 94.2. I'm getting a different answer. Did you do pi r h? Did you take L? What's the formula? Pi r L, right? See where you, yeah, see you. I don't know. I have a different answer. I'll let you know. Next is surface area of the double cone. Surface area of the double cone. Volume and surface, yeah, is equal to pi RL. What is R? OA into AB, correct? Pi into OA into AB, pi RL. This is the surface area of one cone, because only CSE you have to calculate. not TSA, because circles are not visible. Only the curved surface is visible. So CSA of one cone plus a CSA of the other cone. Pi R L. So pi into OA into AC. Pi into OA into AC. You can have a look, see here. This is the radius pi R. This is the radius. This is slant height AB. Again, pi R OA into slant height CA. That's what I mentioned here. Pi RL, children. Now what's common? Pi into OA is common. So in the bracket you will have AB. This one we have the value. So if you want, you can substitute also. Because you know AB and AC. How much is AB? 15. How much is AC? 20. If you want, you can even substitute. But whenever you can take out something common, take out the common factor. So calculation becomes a little easier then. So pi into OA is common. So you get AB plus AC in the bracket. So pi is 3.14 into OA. How much is that? 12 into AB plus AC. How much is AB? 15 plus 20, 35. Correct? Yeah. 3.14 into 3.14 into 12 into 25. How much? Yeah. 1318.8. Correct. 3.14 into 12 into 35. 1318.8. 1318.8 centimeters square. So again, important question. Finished? Yeah. Finish writing? Online students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So first step is to find the hypotenuse. Step 1 is to find the hypotenuse using Pythagoras theorem, 25 centimeters. Then show the double cone, represent the double cone formed. See, this is step 1, finding BC using Pythagoras theorem. First, draw the right triangle. You have a right triangle and that is turned about its hypotenuse. Okay, you're angry with the question or with me? Yeah, Krishnatik. Okay. Okay. Yeah. So first show the right triangle. You have a right triangle. Show the right triangle. Find the hypotenuse using Pythagoras theorem. And then when it is turned about the hypotenuse, the solid generated is a double cone. So we have represented the double cone here. All right. Now remember that for this, to answer anything about this, this figure, it is enough if you have the radius. It is enough if you have the radius. And to find the radius, find the area of this triangle in two different ways. All right, so like that you can find AO. When you find the area of the triangle in two different ways, you can find AO. Not clear with that? Yes or no? Okay. See, if you want, you can substitute it here also. See here. Oh, I already. Okay, see, like under this area of triangle ABC, here itself you can put 150 also. Here also you can just put 150 is equal to half into 25 into AO and work that. So AO you get 12 centimeters. So this is enough. Now volume of the double cone will be volume of the small cone plus the volume of the big cone. Or the volume of the left side cone plus the volume of the right side cone. So 1 by 3 pi r square h. So instead of writing r1, h1 and all, you can write r1, h1 and all that. Instead of that, we have substituted the line segment straight away. R square into h. Line segment straight away, substitute the values, take out common 1 by 3 pi. AO square is common. So in the bracket, you get OB plus OC. That is important. If you try to solve it like this, you don't know what is OB and what is OC separately. OB and OC, we don't know separately. We can find. Now, if you have this question, can we find them? Yes, you can find. We'll understand that also. You can find them using similarity. We'll do that also. So now take out common and then OB plus OC is 25 because BC is 25. This is OB, this is OC. So that is BC. So BC is 25. And that's how you find the volume of the double cone. Surface area of the double cone. Same idea, pi RL. So to answer the question, is it not possible to find? It is possible. I'll let you know. Are we ready? Now we'll just see how we can find. Now, okay, now what do we now? If you're using similar triangles, you don't have to do this. Are we clear with this, children? Are we ready for the next one? Yeah. Now, if you're going to use similar triangles, the concept of similar triangles, just find the hypotenuse BC using Pythagoras theorem. That's all. You don't have to work this. Area of triangle ABC is half into AB into AC. That part you don't have to work. You don't have to work that. Just find the hypotenuse. Okay, so you know the hypotenuse BC is 25. So by Pythagoras theorem, just find BC. Okay, BC is equal to 25. Just find this. Don't find anything else. Now, take up. See, we have three. Don't see this part. Okay, we're just using the triangle above. We're just using the triangles above here. So we have three right triangles. Above, we have three right triangles. Three right triangles. We have the small one AOB. We have this slightly bigger one AOC, and we have the biggest one ABC. All these three are right triangles. This one AOB is a right triangle. This one AOC is also a right triangle, and the whole thing ABC is also a right triangle. So for convenience, you take one small triangle and the whole triangle. That will be convenient. You can use any two triangles, show that they are similar, use the proportion and find the length of the required line segments. We have three right triangles. You can take any two of these three right triangles, take any two, show that they are similar. Once they are similar, write the proportion of their corresponding sides, then fill whatever line segments you know and find the unknowns. But if you want to prove similarity quickly, faster, take any one small triangle and the whole triangle ABC. See, that means compulsory take the whole triangle ABC. With that ABC, take any one of the two small triangles. Take the whole triangle ABC. So in right triangle AOB and the whole triangle and right triangle ABC. All right. In AOB, this is 90. This is 90. Let me call it angle 1. In ABC, this angle 2 is 90. So angle 1 is equal to angle 2 is equal to 90 degrees. Because in AOB, this one is 90. In ABC, this one is 90. And then in both the triangles, we have this one common. Angle 3 is common. Angle 3 is equal to angle 3, common angle. You can see in the small triangle, you have this angle 3. In the whole triangle also, you have the same angle 3. So double similarity, the two triangles are similar. All right. So how do you name the two triangles? We'll start naming with the angles we have used here. Okay. We have used here. So look at the small triangle. Look at the small triangle. We have used the right angle. Angle 1 we have used. So start from there. O. Then which is the angle you have used? 3. See the small triangle. We mentioned angle 1. So O. Then we mentioned angle 3. So B. And the third vertex A is similar to O is angle 1. It is equal to what in the big triangle? 2. So you should, if you say O in the first place here, you must say A here. Because angle 1 is equal to angle 2. So O means A. Then you have mentioned B, which is angle 3 in the small triangle. So in the big triangle, it's the same thing, B only. And which is the third vertex of the big triangle? C. This is the order in which you should name the triangles. This is the order in which you should name the triangles, not any order. So OBA is similar to ABC, double A similarity criteria. Now write the ratio of the corresponding side. So we have OB by AB equal to AB or BA, whatever. Is equal to BA by BC is equal to OA by AC. Right, now let's substitute all that we know. OB is how much? How much is OB, children? Tell me. Do we know OB? OB. AB 15 is equal to AB 15. BC 25. OA அது கண்டுபிடிக்கலையா? அது அங்க கண்டுபிடிச்சோம். இங்க எங்க கண்டுபிடிச்சோம் 12. We should not work that. அது work பண்ணக்கூடாது. That will be too much. You should use only Pythagoras theorem and find that is a different idea. அது வேண்டாம் இங்க. Just find BC using Pythagoras theorem and straight away use similarity. Yeah, tell me. OA தெரியாது. So write OA as it is. You don't know. AC 20. Now see here, can we equate and find OB and OA? Yes. 15 by 25, we know 15 by 25. So equate 15 by 25 with OB by 15. You will get OB. And then equate 15 by 25 with OA by 20, you will get OA. So you can find OA and OB. You can find OA. So using this proportion, you can find OA, correct? Which is the radius of the two cones. And you can find OB, which is the height of the small cone, and 25 minus the height of the small cone is the height of the big cone. So if you want to find all the parameters, that is the radius, height, you can find. Slant height, we already know. 15 is the slant height of the small cone. 20 is the slant height of the big cone. Slant height, we already know. So what we need to know is the radius of the two cones, which is the same. And the heights of the two cones, which are different. So if you want to find these parameters, use similar triangles. If you want to find all. In this method, we found only the radius. We found only radius, and by taking out common, we could manage to find volume and surface area without the help of the altitudes. Individual altitudes, we found the volume and surface area. So this is one idea. This is a method. This is a method. If you're using similar triangles, just find BC using Pythagoras theorem. Don't do this area of triangle ABC. Don't work this. Don't work this one. Just find BC using Pythagoras theorem. Okay. Then I said above you can see 3 right triangles. You can see 3 right triangles. So take the big one ABC along with any one of the two remaining triangles. So we took two triangles like that. We proved that they're similar. We wrote the order correctly, and then we wrote the proportion, substituted the values we know, and we can find OA and OB, which means using similarity, you can find the radius and the heights of the two cones. இப்போ நீங்க கேட்கலாம், அப்ப நம்ம இப்ப ஃபார்முலா யூஸ் பண்ணா காமன் எடுக்க கூடாதான்னு. காமன் எடுக்கலாம், காமன் எடுக்க கூடாது, காமன் எடுக்கலாம். So you will see that, okay, that's what it is. So you're going to work this now. So this is the other method, children. Using similarity is the other method, where you can find radius, height, and then work volume and surface area. Please mention alternate method. So like this, you can see with the concept of similar triangles is used here in volumes and surface area. This is the second method, children. Method 2. Sorry? Yeah, you can simplify. That's what you can simplify here itself. 3s are 5s. You can do it here also. Do it here, then maybe you can simplify. Then 3 by 5 is equal to OA by 20. So if OB is 9, OC will be so you can see like this, we can find the radius and the height of the two cones, and then the proceeding is the same. Done, children? Online students finished?
Completed, ma'am.
Yeah. Take this question. Yeah. I think the idea is similar to the one which we took up earlier based on the CSA. So you write down and then we'll discuss. Question? Yeah. Done, children, till here?
Yes, ma'am.
Yeah. No, this side I've just worked it in another way. Like these are the same. You don't have to do both. 1 second. Just work. See, okay. These two work. These two are the same. Like you can either work it like this or like this. This or this. That's given, no? In the question. You can check. It's given. Height of the height of a cone is 30 centimeters. On the left and right, it's a continuation of the earlier one. You can do it like this or like that. Like yeah. So it's given that the height of a cone is 30 centimeters. That is BD. BD is 30. A small cone is cut off at the top by a plane parallel to the base. See the plane, that is, you can cut like this also, right? Like you can go. So you can also cut if this is the cone, you can cut it like this also, right? No, the plane is not oblique like this. The plane is parallel. The plane which cuts through the cone is parallel to the base of the cone. That's what is the meaning. You're not cutting it like this. Then this plane is not parallel to the base of the cone. You're not slicing it like this. The plane which cuts through the cone is parallel to the base of the cone. So a small cone is cut off at the top by a plane parallel to the base. This plane is parallel to the base. If the volume be 1 by 27 of the volume of the given cone, that is the volume of the cone which is cut off. What's happening? What do you have? You have a cone whose altitude is 30 centimeters. Now, a plane parallel to the base is used to cut off and the top of the cone, which is the top portion of the whole cone, which is a small cone. The volume of that one is 1 by 27 of the volume of the given cone. That is the volume of the small cone is equal to 1 by 27, the volume of the big cone. A small cone is cut off at the top by a plane parallel to the base. This we understand. If the volume B, meaning if the volume of the small cone B, if the volume B, meaning if the volume of the small cone B, if the volume B, meaning the volume of the small cone B, 1 by 27 of the volume of the given cone, that is the whole cone, the big cone. At what height above the base is the section made? At what height above the base? This is the base. At what height above the base? Above the base. Here the section is made. Here the cut is made. Here. Here. At what height above the base? So you should find BC. At what height above the base? This is the base. At what height above the base is a section made? Is that cut made? So you should find BC. You have to find BC. At what height above the base is the section made? So you have to find BC, which is actually the height of the frustum. So it is the total height. That is at the height of the big cone minus the height of the small cone. We have to find BC. We have to find BC. And BC is the height of the big cone, BD, minus the height of the small cone, DC, correct? The height of the big cone minus the height of the small cone will give you BC. It's still cold, you can just move. It's still cold. Okay. So the height of the big cone BD minus the height of the small cone CD will be the height of the frustum BC, which is the required height. That's what we have to find, correct? Okay. So it's very similar to the one which we worked earlier. I'll not take a long time, it's time. Yes. The figure we understand, children, and then usage of small letter and cap letter, that also we understand, radius and height. We are not talking about the slant height because it's only about volume. So no slant height we are talking about. And this one we understand. Show that this triangle is similar to this triangle. Show that similar to the early one. Show that this triangle is similar to this triangle. Double A similarity, right angle and common angle. Correct? These two triangles are similar. So if the two triangles are similar, then corresponding sides are proportional. So we've written the ratio of the corresponding sides. So we've written only two. What is the third one we have not written? We have not written DE by DA, the ratio of their slant heights. That we have not written. We don't want to, so we have not written. We'll have three ratios, right? In similarity, we'll have three ratios. So we have not mentioned DE of the small triangle by DE of the big triangle. That we have not mentioned because that's about slant height. We don't want that. Nothing wrong. You can write, but it's not needed here. We have not written that, but we have written DC by DB is equal to CE by BA. That we have written here. In two similar triangles, corresponding sides are proportional. That we have mentioned. Then substitute. H by H is equal to R by R. Have this result. Have that result. Show that the triangles are congruent. Sorry, show that the triangles are similar and write the ratio of the corresponding sides and have this result. All right. Now, this is given to you in the question. Volume of the small cone is equal to 1 by 27 of the volume of the big cone is given to us. I've used the formula. Now bring this for division. This volume of the big cone, bring it for division to the other side. So you have A is equal to 1 by 27B. In the next step, you write A by B is equal to 1 by 27. Right? A by B is equal to 1 by 27. So that's what we've done here. So volume of small cone is 1 by 3 pi small r square h, and then 1 by 3 pi capital R square h for the big cone. 1 by 3 pi gets cancelled. So we have r square by r square and h by h here. And you understand the rest, right? So this r by r can be written as h by h because they're equal. R by r is equal to h by h. So we're replacing. R by r is written as h by h. So h by h the whole square into h by h will be h cubed by h cubed or h by h the whole cube. So h by h the whole cube is equal to 1 by 27. H by h the whole cube is equal to 1 by 27. But we know the value of capital H, 30 is given. See, now you will say, what if I forget to substitute here? It's okay if you forget to substitute there, nothing wrong. Because suddenly I've written 30 there. Now, supposing, what if I said, will not do this. Now, supposing you forget to substitute, that's fine. Like you're here, you're like this. Okay, now I forgot. So I write H by H is equal to, what is H by H? 1 by 3, right? 1 by 3, right? Now you can substitute. What is H? 30. Now you can do it. Is equal to 1 by 3. Understand? So H is equal to 30 goes here. So 30 by 3, H is equal to 10. Any point you can substitute. Nothing that this is the right point. You can substitute it here also. Anywhere you substitute H, you can put it here also. This is 30 here also you can put. Anywhere. Then you'll get 30 here itself. You'll have 30 here. Whenever you realize you substitute. Yeah. So like that, we find the value of small h. Working this, we get the value of small h. So what is it we have to find? This one is 10. Value of small h is 10. The whole thing is 30. So this one is 20. So the section is made at a height of 20 centimeters from the base. All right. All right, children. So that's it for today's session. Thank you so much. Good night, children.
Thank you.
Thank you. Just stay. I just have an announcement to make.
Thank you.
Yeah, thank you. So the